All right, we are continuing with our big idea that describing shapes and objects can help us to understand the world and to solve problems. Our concept today is to demonstrate an understanding that attributes, again, such as number of sides, number of vertices, length of sides, they're perpendicular, and so on, can help us to describe 3D objects. So again, parallel, perpendicular, intersecting, horizontal, and vertical lines and edges. In this case, edges, because we are now talking about 3D shapes. So it's no longer a line, it is considered an edge. We will also be talking about the faces and telling whether or not they are parallel, perpendicular, intersecting, horizontal, or vertical. And a face, again, is the flat side of a shape. We will also touch slightly on how to draw 3D shapes. We'll do our best we can with that one. It can be a little bit tricky. All right. So again, some of this is not in the Connect section, so some of it may not look familiar to you because I've used a few other resources that I think help to describe and explain this concept a little bit better. So first of all, when we talk about 3D objects, we usually break our objects into two types of groups. We call some objects pyramids and some objects prisms. Turn and talk to your elbow partners and press pause very quickly. Why do you think some are called pyramids? Why would these be considered pyramids? Why do you think some are called prisms? Why do you think these would be called prisms? Press pause and turn and talk to your elbow partner right now. All right, what did you come up with? Well, the reason that these are called pyramids is they come up to a vertex or a point. There is a flat base and a point at the top where all faces meet at that vertice. Whereas with prisms, there is not a point. We have two parallel bases of the same shape, and there isn't all the faces coming to one particular vertice or one point. So that's the difference between prisms and pyramids. All right, so just to confirm, a pyramid is a solid figure. It's a 3D shape. It has one base, that would be the bottom shape, and all other faces are triangles. All faces share one vertex. They all meet at the top. And the name of the pyramid, it is determined by the shape of the base. So the shape of the base is very important. This would be a square pyramid because the bottom is a square. This would be a pentagonal pyramid because the bottom is a pentagon. This would be a triangular pyramid because the bottom is a triangle. One of the ways to help you keep pyramids and pentagons straight, pyramids and prisms straight, is that prisms have flat tops and pyramids have pointy tops. So hopefully that helps. It helps with remembering the difference. Now, when we describe 3D shapes, we are no longer talking about lines. We are talking about edges and faces. Now, a face is the entire flat side. So a face is like a side. Okay, so we could talk about, now we've talked about parallel lines being the same distance apart. We can also talk about faces being the same distance apart. Here, this yellow face is parallel to this blue face. And in fact, you could say that this side right here would also be parallel to the opposite face. And in fact, on a rectangular prism, which this is, all opposite faces are parallel. So top and bottom are parallel, side and side are parallel, front and back, which is hard to see here, are also parallel. Some parts can also be described as being perpendicular. So just like perpendicular lines met to make a 90-degree angle, faces, the entire sides, can also meet to make a 90-degree angle. In this case, you can see the side face and the bottom face will make a 90-degree angle. Therefore, we could say the side face and the bottom face are in fact perpendicular. When we are talking about prisms as opposed to pyramids, all prisms have their bases being parallel. As we said, top and bottom is parallel. Front and back is parallel. Side and side is parallel. All of them are parallel to each other on each and every single shape. This one can be a little tricky because it is a pentagonal prism, but still the front and the back are parallel. The other sides aren't necessarily. So if you look at this particular side here, this almost top one, and this one here, they are not parallel. In fact, none of the sides on this shape are parallel. But the bases, the front and the back, are always parallel. Here, same thing. Front and back are parallel, but none of the others are. This would be perpendicular, those faces, and these faces, because it's not making a 90-degree angle, would be considered intersecting. So the bottom and the side face would be intersecting. The two side faces would be intersecting. So they would not be parallel or perpendicular. We could try something with a cereal box. If you had a cereal box or even a Kleenex box or any kind of a box really, if you were to touch the front of the box and the back of the box, you would see that those sides are in fact parallel. They are the same distance apart. Now when you are talking about faces meeting an edge, so where the front and the top meet, for example, if it forms a right angle, they are perpendicular. If they do not form a right angle, they are intersecting. Just as our triangular prism up here, we can see they do not make a right angle here, they are intersecting. They do not make a right angle here, they are intersecting. They do make a right angle here, it's perpendicular. And with 3D shapes, your best bet is probably to use a colored pencil crayon when you're showing it and draw it right on top of that shape. So for example, I'm going to say, all right, I'm going to use blue to indicate perpendicular. All right, there we go. Blue to indicate perpendicular on all of my shapes. So, okay, this is perpendicular. Now I can't go on top of that with something else. I could say this is perpendicular. This is these faces are perpendicular. These faces are perpendicular. These faces are perpendicular. And by showing that, I've clearly indicated what is perpendicular. Then I could change my color and I'm going to say, okay, I'm going to color the sides that are parallel. So I'm going to say green is parallel. This side is parallel to this side. Now, in the past when we talked about going above and beyond, it was like, please go above and beyond as much as you can. But in this case, if you go above and beyond, it actually becomes confusing. Because if I were then to say, okay, well, this front face is parallel and this back face is parallel, can you now see what's parallel? No, because there's too much there. So you have to be careful. In this case, you can only show one example of each, because otherwise it confuses your understanding, what you understand. It confuses the evidence of your understanding. So one example of each, unless you were to choose a different color, I could say the green faces are parallel, and then I'm going to choose pink. I'm going to say my front face and my back face are also parallel, but again, that makes it more tricky to read. So keep that in mind. Normally going above and beyond and showing more of that example is excellent. In this case, it makes it confusing to determine, do you truly understand or do you not? So in this case, please do not go above and beyond by adding another example of parallel or perpendicular lines or faces. The other thing we can talk about, so far we've talked about faces, now we're going to talk about edges. An edge is parallel to another edge, so that's the line where those two meet. So here you can see this edge is parallel to this edge. We could also say that this side edge is perpendicular to this edge. And again, this is where your colors are going to come in really handy. I could say, okay, this pink edge is perpendicular to this pink edge. Oh, pink wasn't a great choice. It's not overly clear. Okay, whereas here I could say these blue edges are parallel. The pink edges are perpendicular. That shows that difference. Just like vertices on 2D shapes, a vertex is the point where the corners meet, all three edges meet. So that's considered a vertex. No longer a vertice, but a vertex. All right, so let's look at a couple examples. Look at our classroom walls, for example. Follow the wall down to the floor. Look at the line that is formed where the wall meets the floor. So if we were to draw a line where the wall meets the floor, we would see that that is in fact a right angle. We can see that right angle is drawn there. Okay. It is a perpendicular, so we could say that the wall is perpendicular to the floor. We could say the wall is vertical, it's straight up and down. The floor is horizontal, it's straight side to side. So then when those two meet, we know that that's going to be perpendicular. Look at the vertical line where two walls intersect. And these lines are also perpendicular. So where these two walls intersect, it is also perpendicular. You will also get a 90-degree angle. Let's take a look at this triangular prism down here. Oops, I'm going to erase that because those red lines might confuse you. Red and red. Here we have a triangular prism. It is not a pyramid. It doesn't come up to a point. Okay. We could say that each blue edge is perpendicular to the red edge. So blue edge perpendicular to red, that's where that's making a 90-degree angle. However, blue edges to blue edges are just intersecting. Okay, blue to red is perpendicular on all parts, blue to red. Doesn't matter which blue to red line you choose, they are all perpendicular as you can see. However, all blue to blue lines are intersecting. They do not make that complete 90-degree angle. We could say that this triangular base is parallel to the opposite triangular base or face. These rectangular faces all intersect. None of those would be parallel. They would cross each other if we were to extend the face on each side. Here they've described the shape just a little bit further. The red rectangular face is horizontal. Okay, so we've got one horizontal face. We have the blue triangular faces that are vertical, and they are both vertical, so we can say that they are parallel. The triangular faces are perpendicular to the red rectangular face. What? No, sorry, each triangular face is perpendicular to the red rectangular face. So if you went from the triangle down to the rectangle, those would be perpendicular. However, rectangle to rectangle would not. They would be intersecting. Okay, so just again to remind us, the face is the side that is flat, the entire side. The edge is the line where those sides meet. And the vertex is the corner where all of those edges meet. All right, now we get to do some practice. So first, just making sure that we have the right part when we are talking about the shape. Faces, edges, vertices, and then trying to name that figure. So press pause and try that now. All right, let's take a quick peek. What type of a solid figure is this object? Well, all sides are the same size. It is a cube. How many faces does it have? Well, faces are flat sides, so it has 1, 2, 3, 4, 5, 6. You're welcome to look at one of the actual object if you need to, or if you have one available. You can grab one of our base 10 blocks to help you. How many edges does it have? Well, I'm going to go red for edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. How many vertices? Well, vertices, I'm going to go black. So it's got 1, 2, 3, 4, 5, 6, 7, 8. What types of surfaces does this shape have? Well, if we wanted to, we could talk about the fact that each opposite face is parallel and each connecting face, adjacent face, is perpendicular. So those are the types of surfaces it has. It has parallel and perpendicular faces. Ooh. I ran out of room there. Next shape, what type of a solid figure is this object? Well, we know it's not a prism. It is a pyramid, so we can add that. What kind of a pyramid? Well, remember the pyramid name is based on the bottom. This looks like a rectangle, so I would say it would be a rectangular, a rectangular pyramid. Rectangular. Sorry, I'm going to run into the word there. How many edges does it have? All right, and edges I had as red. So edges, it has 1, 2, 3, 4 around the sides, 5, 6, 7, 8 counting ones on the bottom. How many triangles make up this figure? Well, we have 1, 2, 3, 4 triangles around the side. How many rectangles? Well, 1, which is the base. How many faces altogether? Well, if we have 4 rectangles and 4 triangles and 1 rectangle, we have a total of 5. How many vertices? Vertices I'm going to make black. 1, 2, 3, 4 around the base, and then of course 1 up top. So 5 vertices. And the last kind of a shape we haven't talked a whole lot about, but I thought I'd throw it in there because sometimes you'll come across this kind of a shape and it's pretty hard to describe in some ways. This is what we call a cylinder. If it was a cylinder that came up to a point, it would be called a cone. So you might come across a couple of those. A cylinder has 2 bases and then all other sides are curved. It doesn't have straight sides. How many circles does this have? Well, it has 2 circles in its top and bottom base. And what other types of surfaces does it have? Well, they're all curved. So they are not parallel, they are not perpendicular, and they are not intersecting. So when you have curved shapes, none of those characteristics or those attributes apply. So that's what we call a non-example. It shows what parallel, intersecting, and perpendicular faces are not. All right, next question for practice. We'll read it together. Here's an example. Cameron is on the phone with Daksha. He tells Daksha that the ceiling in his room is horizontal because the room is shaped like a rectangular prism and the floor is a base. Daksha says that the ceiling is parallel to the floor. Who is right? Turn and talk to your elbow partners. Do you think both of their statements are right? Do you think one is wrong? If you think one of them is wrong, who is wrong? And of course, tell me why. Why would you think they're right? Why would you think they're wrong for each person? Go ahead and press pause and talk to your elbow partners now. All right, so we have Cameron who was saying that his ceiling is horizontal, as is his floor would also be horizontal. And in fact, he is correct. They are running side to side. They would also be considered parallel. And so when Dashika says the ceiling is parallel to the floor, she is also correct. They are equal distances apart. So they are both right. All right, lastly, we're going to come to how to sketch an object. So when you're sketching an object, when it comes to being a prism, you draw the front face and the back face the same size, and then you don't draw them right on top of each other, draw one over slightly, and then you would join all of your corners. That would be for a prism. Okay, so for example, if I wanted to do a rectangular prism, I would draw my one rectangle, I draw my other rectangle over and up, same size, and then join all of those corners. If you're drawing a pyramid, all you have to do is draw your base and then put a dot directly above in the center and then join all of those corners to that base, and that gives you your prism. I'm not going to be overly concerned about your ability to draw. It is something we have to take a look at and consider, but it can be very tricky, so not a big concern for me. All right, that being said, you're moving on to your concept practice. Page 244, number 2, and page 248, numbers 2 and 3, describing 3D objects. And again, I would recommend for 3D objects using pencil crayons of different colors to describe your shapes. You might have to somewhat draw them in order to be able to describe them. So that's where the drawing part comes in. If you're having some trouble with that, let me know as well. And of course, as you're working at any point, if you have trouble, please make sure to ask myself, if there's another adult in the room, the adult, and if possible, and I'm not available, adults aren't available, please remember to ask a classmate. Don't ever say you don't know. Make sure you are seeking to understand by asking questions. And if one of the adults is not available, a student will help, or even the Connect section of your textbook can help as well. All right, after you've done your Connect section, we've discussed it and looked at it together, you can move on to your exit slip. Here's page number 1, and here is page number 2. And once you've completed that, we are in fact finished the unit. So you may move on to the skill review, which will review all of the concepts in this unit, which had to do with describing 2D shapes and 3D objects using attributes such as parallel, perpendicular, intersecting, horizontal, vertical, the number of sides, the length of the sides, or faces, or edges, and so on. So doing the best you can, working on the skill review. Again, as always, if you have questions along the way, please remember to ask.